All righty. Good morning, good afternoon, good evening. Welcome down the security rabbit hole to yet another edition of the Down the Security Rabbit Hole podcast. This is Raf. Welcome to the board. Welcome to the show. And James, welcome back.
Yeah, thanks. Hoping we're going to get a little bit of rain from our drought we've had for a while, and looks like it's
Did
going
you
to
just
be a
have
good
a
day.
hurricane
Hopefully,
go over your head?
we got hardly any rain. I kid you not, I ran my sprinklers after that thing went through.
Wow.
That's how much
Uh,
rain we got from that storm.
that's equal distribution is not guaranteed in
Yes.
life or weather. Uh, all right, this episode we're going to talk about secrets, keeping them, utilizing them, and some terminology. Frankly, I'm not familiar with. So to talk all that through, a guy whose name I'm not even going to pretend I can pronounce. Uh, Oded, welcome to the show, and you want to try to pronounce your name the way it's supposed to be pronounced.
How even? Okay,
Sure,
you want to
that
try
sounds
it?
good.
You want to give it a try?
I do not.
How even? Just imagine it's a German name or something, and suddenly everything will work. Don't worry. How even? But yeah, some
Okay.
people here in the States, they say it hard even or something. But I'm fine with everything. Good to have you. Good to be here with you both, guys. And thank you, Rob, for having me and James. I'm here all for you and to speak about secrets and whatever needed.
So don't tell him your
So
secrets, I think is what's going on here. Like, this guy's the wrong person to tell secrets.
No, I'm going to
Yeah.
tell you the secrets behind the secrets, right? That's the whole thing you're going to hear from me, but not the actual secrets.
All right, listen, I appreciate you joining us. There's some topics in here that I was interested in, and I wanted to hear more on. So I Googled all these, so at least I have some basic understanding. So the secret zero problem that you talk about, you've written quite a bit about this. I want to start on, to make this kind of relatable, I want to start on the user side, right? We
Yeah.
all use password managers
Uh-huh.
because we have hundreds of thousands of places, millions, some of us, of places we've created user, every website you've ever logged into, every vacuum cleaner, every coffee maker,
Yeah.
every time you've ever used a store card,
Yeah.
loyalty card, brand, whatever, you have to create a username and password. So to manage all those, we have password safes, which was like,
You're
okay,
right.
I've collapsed the number of passwords I have to remember down to one. And then you just hope that
Allegedly.
password isn't
Yeah.
password 123.
Yeah. Yeah. Well, if you've done a good job, then yes. Or you've plugged it with Face ID or whatever MFA solution that you could use. That's fine. But this is for humans, right? This is for humans, which
Yes.
is great. There are plenty of solutions today for humans, like single sign-on and things as such, right? The market have invested a lot with humans and solutions for humans in terms of identity and access management, improving your identity, etc. But the thing is that the last few years, and let's say around 7 years, with the trend of cloud transformation, with containerization, suddenly we are seeing today with automation of machines, right? Those machine identities, you now have automated processes, CI/CD processes. There are obviously a lot more micro functions that are running. Okay, we're talking about an order of magnitude, much more machines than actually we have humans. So if we used to have on a certain organization, certain amount of humans and smaller amount of machines, today it's quite the opposite, where machines are enlarging like very fast. So what happens is that those machines have their own secrets. This is something that we used to think of in the previous on-prem environment, right? So we're using some API key or an SSH key or a password in order, to do something within our scripts, within our automation. And we thought that within the on-prem it's okay. Today everything is distributed. So now we have millions of those secrets because of those millions of those machines, automated processes, and you need to somehow provide a scalable infrastructure that would be able to manage those secrets and provide it on runtime. Okay, this is the whole thing about protecting the objects that are being used within authentication of machines. I hope
So,
this
so
clarifies the
not
whole thing.
so not environment variables is what you're saying.
Environment variables is okay. It's a good example of of bad practice, right?
Right.
Uh, if you are configuring them in a very constant, open, non encrypted way, but actually, if you inject the secrets into environment variables in a certain way, you would be able to protect them, assuming that you've done it again with a good way in terms of encryption, etc. Right? So it's a method of basically transferring your secrets to the target that requires.
Yeah. So how do you manage to? Because now I'm thinking through that. Back in the day, these were all just text files someplace.
Yeah.
And now you've got secrets in memory. You've got APIs talking to APIs, authenticating each other. You have to worry about not just authentication, but authorization. You have to worry about rotation rotation of these secrets. Do we have? Is this sort of like one of those one machine to rule them all things? Like, are we trending towards some sort of like how do you manage that? Because I'm trying to conceptualize that in my head. It just is like that. It doesn't really.
I'll make it
well.
easier if that's okay with you. It's not in line. Okay, it's not that all the applications now they need to change, and whenever they wish to get access to a certain database, then they need to go through the secrets management system. This is not the architecture of those kind of systems. Basically, it means that whenever, let's say, a container, right, that spins up, requires a connection to a database. Okay, and when I say container, it can be a virtual machine, it can be a bare metal, it doesn't really matter. So whenever it spins up and it requires those credentials in order to connect to the database, right? There's a question of where will it bring it from? Now, back in the days, it was within the source code or exactly text file, as you said, configuration files, etc. Right? So we all understand today that this is bad practice. GitLab, GitHub are full of those API keys, which obviously can easily be compromised, etc., etc. We all know it's a risk, and the statistics talk about 70% of all breaches somehow, right? They're leveraging some kind of credentials that was not being used or certificate that was old, and etc. So all of that world, okay, eventually all of those workloads require the secret in a way that will be secured, that this secret will not be revealed. And once it is being provided to the workload itself, to the machine itself, the secrets management systems does not continue. It provides the secret, it decrypts it, and from now on, the container itself is free to use it as much as needed. Okay. Now I'll pause here. Allegedly, that's the whole story, but it's not, because what things that are happening is that the container, whenever an error occurs, it will write into the log, right, the credentials, the environment variables, or the variables that it was using while it was running the function, right? So you're still in a high risk of losing your control of those credentials or those certificates, right? So for that, there are mechanisms of rotation, which is the job, right? One of the very important jobs of secrets management system. The other one is to be able to provide dynamic credentials, just-in-time created, temporarily used certificates or tokens. Okay. Now imagine we once talked about, okay, so when you're starting to use all kind of those applications users, right? So you're defining 1 and 2 and 3, and then you never delete them. So you're getting environments that have a lot of those system users, right? That it's not connected to humans, rather than automated processes. And the nature of the IT/DevOps environment is that you never delete those users. And this is where problems begin, right? So the whole concept of providing temporary credentials or dynamic credentials, aka just-in-time, etc., is to basically provide them on demand and then to delete them once they are not being used any longer. So when at the end of the year, an auditor comes, and then you can see on your database that there are no users that you are not aware of, right? So it's the holy grail of audit and compliance.
That, James, this sounds like it's in your wheelhouse, because this quickly spins out of control in my head. But are we talking? I mean, look, to bring this back into the user space.
Yeah.
To something I'm familiar with, right? We used to have service accounts for everything, and like back in the olden days, when we didn't have all these things, but somebody still had to know all those passwords, write them down. They weren't easily rotated. If they got compromised or somebody, I don't know, stole one, you have to go back and add it and follow the process all the way through again. This notion of use it and then throw it away is interesting. How does that scale? Because that is not that doesn't seem like I mean, while like from a security perspective, it sounds like a great idea.
Yeah.
You like both sides have to agree that like, okay, I generated a password or some kind of token. You have to send it over here in a different channel. So this side says, okay, I can verify this token. Talk me through that, because that's.
I'm with you, Ralph. Let's have some order inside. Okay, there are a lot of differences between the traditional environments, right, or like service accounts within Windows services, right, or Linux services.
Yeah.
And obviously with the newer way of how applications are being built, right? I think I lost James. Is it okay?
No, it's okay. He'll come back.
Okay, James, come back. Anyway, so what I'm saying is this: let's go for the basic part. Hey James, the basic part is that if you had a user or a password for a certain system account, exactly as you described it, right? So this is where usually it is a built-in, out-of-the-box service, right, of a certain operating system. And then what you want is that for that particular password to be automatically rotated, because you're not going to change the way that the operating system is written, right? So the operating system will not change its way to start asking for tokens because it's already there, right? The automatic tokens that can be switched or created and then deleted are mainly for the world of application. Okay, what do I mean?
Okay.
If a certain, let's take a Lambda function, and it doesn't have to be, by the way, only in the newer world of Lambda functions. That's still be given code that you write within .NET, right? So your .NET code could have been asked for a secret from configuration file. The first step is to say, no, I'm not keeping it in configuration file any longer. I'm asking it from a vaultless solution. Okay, I'm asking it for a secrets management or a secret repository. Okay, I'm fetching it on runtime. Okay, that's the basic way to do it. Instead of fetching the secret credentials certificates from the source code or from configuration files, to ask it for a secret store or a vaultless solution. Now, the next step is to say, you know what? I don't want to be fixed. Okay, so what's going to happen is that when a certain container spins up, it will ask the secrets management system to provide with a temporary credential. And yes, you are right. If that is being provided, temporary credential, then the code itself needs to be aware and to know that this has an expiry period. Okay, and after a certain time, it needs to be replaced. Now, in the world of Lambda functions or containers, they are spun up. Okay, they are spun off and spun on. Okay, so automatically you can say, I'd like this credentials to be created on the database with the secrets management system. It will create the password and the identity. And after, let's say, an hour or 24 hours, it will be deleted according to the policy, right? Now, in that time, today, functions can be very temporary or ephemeral, if you like. They are running for 1 hour and then they're down. They're releasing the resources. And in those kind of cases, you have the full support of the whole idea of catching, right? Like allocating the resources and then removing it and then releasing those resources. So the same goes with compute resources and also with your security resources, which are the credentials that you need in order to operate. I hope this is clear. Let me know if not.
Yeah, no, that makes sense. So, okay, so we do this at scale. I mean, when I say at scale,
the whole point of it, right, is that the older solutions to manage those passwords, right, like privileged access, etc., right, those kind of solutions until today, as much as they've been comprehensive in terms of managing the process of the human being, the human administrator, to record the session, etc., okay. The true challenge within the secrets management system is actually to be able to provide scale, which means that you need to have this service of secrets management. You need it to be available on every region and every environment that you are active in, okay? Because you need it live and you need it, with high level of availability, right? So it does scale in the way that you are building that system. Specifically, obviously, right, if we'll just, touch it in 20 seconds, obviously, Achilles, as a co-founder of the company, just to provide some idea on that. What we provide is a SaaS service, right? So basically, it means that globally available with 4 nines availability, etc. Okay, so it means that wherever you are at, This is where the service that you get that manages those secrets.
Okay. So clearly our buddy James here is having some internet connectivity problems. Sorry, buddy. Come back soon. Uh, but when you talk about like in this context, what does the phrase zero knowledge secrets management mean?
All right. Okay. So
I'm shifting gears a little bit, but it's the same thread, right?
I'm with you, Ruff. I'm with you. That's great. So let's assume that we've met, and you told me, I told you, listen, it's very hard for me to manage all of those secrets on my own. Okay.
Mm-hmm.
Or this is what you're telling me. Okay, it's hard for you because eventually you need them. You need to carry it in your wallet. You need to put it in your phone, etc. And you wish me, right? And you're asking me to keep those secrets, and whenever you'll ask for that secret, I'll give it to you, right? On your private voteless solution for that sense, okay? And what would happen is that I'll tell you, you know what? That's fine, but I can practically access your secrets, right? Because you're keeping your secrets on my end. So the whole point of saying you don't want to manage your secrets, okay? You want others to do so because it needs to be highly available, always on, etc., okay? But now, where is the promise of your vendor that your vendor would not be able to access your secrets? Okay?
Yeah.
It's basically you put your money in a vault in a bank, and you need some kind of a promise that your bank would not be able to access your money. Okay?
Yeah, and a solid wink doesn't do it for me.
So the whole point, exactly. So the point is basically with zero knowledge means that I have, or the secrets management system have zero knowledge, zero understanding or knowledge or the ability to decrypt your secrets, right? Although it keeps your secrets, it's not being able to open it.
That's interesting.
And by the way, to make it even more spicy, a true zero knowledge solution would say not just that the vendor is not able to access your secrets, rather than also protecting you from any third party and especially from the government, right? There's Cloud Act today. So what if I'm telling you, you know what? I can't see your secrets, but tomorrow morning, if there's a subpoena, right, of the government, I'm obligated to provide them with your secrets, right? Although allegedly I can't look at it, but I need to provide them with the encryption keys, with the secrets themselves, with certificates, etc., right? But a true zero knowledge means that neither I or anyone else who asks me that, either legit, right? Either it's legit with subpoena or not legit, which is like compromise. So you need to have full protection of supply chain attack and government access. This is true zero knowledge.
So that's kind of like that was kind of like the thing where Apple said, "Hey, if you don't have in the FBI case a couple of years ago, they're like, we can't get you into the phone. We don't have a secret. Like, there's no way to do it. Once somebody sets a password on it, we can. That's kind of what you're talking about, right? Even though they have access to the device.
Exactly. It's you and only you. Okay. If you forget that thing that you had to remember, only one thing that you had to remember, no one can help you. That's the whole thing, right? There's no other way. How can you make sure that you can trust someone if the minute that you move, you're asking, you know what, I need you to restore my secrets. If I'll say yes, what does it mean about me? I have access to your secrets.
That's true,
right?
Yeah.
So always ask, can I restore? You want the answer to be no, right?
Yeah,
you want
yeah.
the answer to be no.
Well, that's kind of like you're forgetting your password, and you do the I forgot my password, and they mail it back to you. You're like, wait a minute, I don't want that.
Who wants it?
That means
it's
sitting in plain text.
Bad practice. Yeah. Bad practice.
So
this is how it works.
So okay, so that limits it. I get it. Tell me this though. In an organization, all right, I'm trying to think of how to adequately explain the scenario. So I work for Acme Widget Company. I manage that platform that manages all the secrets, right? I decide one day, I don't like this place anymore. I quit. You guys are off on your own. Bye-bye. Mic drop. Does it have to be like, shouldn't there be like some sort of I don't know. There's got to be a way to get back to it, right? One employee can't compromise the entire company.
No, it cannot. And let me explain why. And this kind of relates to Secret Zero. And if you want, we can talk about that later on. I think you said it's one of your interests.
Yeah.
Every workload that wishes to get a secret, a credential, certificate, or key, that workload, that machine or automated process uses its own identity. By no means, secrets management system should be dependent on any human, right, to be there in order to actually operate it. The whole beauty of it is that your workload, right, your Lambda function, your containers, your VM, your VMware, your vSphere, every automated process that is running is leveraging, this is how you should configure that, to leverage its own identity. For instance, you have AWS IAM, you have Azure identity, you have GCP identity, right? So all of those need to leverage their own. Even if you're leveraging the whole technology of secrets management within your on-prem, in which in many places you do not have any identity for those workloads, right? Mostly it's not there, right? If it's not Active Directory, if it doesn't have an identity within Active Directory, then it doesn't have an identity at all, right? So the Linux world is a bit more open on that. Even then, right, I'll be able to provide you that, like a universal identity that will be able to provide you some kind of identity to that machine. Nevertheless, to make it short, you should never access a secrets management system using your human credentials, right? If you are implementing it for machines, and this is usually what you do. Okay?
Yeah. Okay.
So there is no interference.
Okay. Yes, that makes. I mean, that makes a lot of sense because I can envisage every cloud provider, right? Every API, everybody else has their own ways of doing it. GCP, AWS, Azure, and every other private and public cloud provider has their own way of authenticating into their system, and then their systems authenticating to each other, and all that, right? So, is there like a I can understand why it is such a pain in the butt for those who try to manage security in this way.
Yeah.
Why they have such a hard time. What's that?
Imagine a multi-cloud application.
That's what I'm thinking, right? Is how do you even do that?
And when you have a compute power that needs, like on AWS, that needs access from a SQL server on Microsoft, on an Azure environment, how do they do that? Who's asking for the token from Azure, right? How does this work? So when you have a secrets management system that, right, a Voltage solution should provide you such a solution, meaning that your automated process, your application, your CI/CD that requires access from one cloud to another, it reaches out to the secrets management system and it asks, right, can I get please access to that database? And it says, yes, take that token. That token can be statically created or dynamically created, okay? Take that token, use it. And then you're approaching to that Azure environment from the external world, assuming that this is allowed within your security policy, right? But in terms of credentials, you can get that using your AWS identity. Okay, so I'm leveraging my AWS identity in order to get actual permissions on Azure. So this is kind of
that's interesting.
You can call it like a hypercloud IAM or a multi-cloud IAM.
Yeah. So that look, James, thanks for coming back. You're
let's hope it lasts.
We're gonna try to figure out what's going on over there with you.
Yeah.
But I can't this is one of the frustrations is as everything gets more complex, we're asking everybody to use. Everybody wants to go use the native things for each platform. Like, hey, go use AWS's native authentication, but also Azure's native. And now you have two natives. And then you're trying to, the reality is which cloud providers your company use. And it's all of them. We all like all of them. There's always something in somewhere. And then security gets screwed trying to figure out how to manage this.
Yeah.
Because the development team just wants to do their jobs. Ops just wants to do their jobs, right? James, are you? Is this resonating? Like, does this make sense to you? Like, all like trying to manage all this crap Are you seeing this kind of stuff? You're coding in the cloud.
Yeah, no, I mean, this is definitely stuff that you see as a trouble spot, right? I mean, obviously I got kicked for a while here trying to figure out technical issues, but I mean, you think about we talked about the environmental variables. You think about like, is your key vault and some of these other things. It's actually interesting to think about kind of this idea though, with like the identity and access management piece around it, having something almost like an HTTPS handshake, right? Where you're like, hey, listen, we don't have anything defined yet. Let's figure out how we're going to do this, and we'll share something and we'll give you access as long as you can prove you are who you say you are, and then that stuff is temporary, right? Like, hey, that works, that credential works until your session's done, and then it's done, and it basically breaks it down every time. It's interesting you talked about the container piece, right? Like you spin up a container, it asks for the credential, and that credential lives for so long. How do you handle, okay, I've got a container that does spin up for an hour, and it's very short-lived versus I've got that old school ASP.NET monolith that spins up, and man, you don't shut that thing down for 25 years.
All right. God created the diversity and the options exactly for them, right? So the system that you're using need to support both the traditional use case of having, you're having those servers that never go down, right? And to have to use a static secret or a rotated secret that the secrets management system would basically rotate, right? And for the newer environments in which are easier for you to actually, start from new page, right? And to start building it right, this is where you work with those dynamic credentials. So it evolves together with the organization. It makes sense.
Does it get to the point where there's a full hands-off approach? Like right now, right? Like if say I use Azure Key Vault, somebody in ops is going in and putting in that credential, right? Like they create the credential, they put that credential in, the app says, hey, go grab this key from this key vault. Is there a point where it becomes fully automated, that there's nobody doing anything, like nobody knows the passwords, the systems just generate and all run on their own?
The answer is yes. Whenever you're starting to leverage automation within your provisioning, okay, like methods of infrastructure as code, right? You're basically building a new environment, right? Then within that script, all you do is that you're provisioning a new machine and you're asking for a new token that will be injected automatically to that machine. So not even the provisioning platform potentially can also completely avoid of knowing those credentials. And by all means, right, humans are not exposed to those credentials. By the way, not even with just the infrastructure as code, right? CI/CD processes, right? A Jenkins that requires access to your source code, okay? It requires API key. The API key is not exposed to any person, maybe just the first one that was configuring it, right? For the first time. But after that, it is being rotated automatically. And of course, there is human at the beginning that starts the whole thing. It's the first human that needs to start the rise of the machine, right? Otherwise, it will never happen.
I'm interested because this is interesting tech, because I mean, just a number of reasons, not the least of which is humans are horrible at keeping secrets. And I like that, James, you missed out on the part where he was talking about like the fact that you can't, even if the request is legitimate or illegitimate, like the provider can't be like, oh, hold on, let me read back the secrets for you, the access for you. That can't be done. Even if like, hey, Gov says I want in on this, but it's also interesting because neither can. I mean, allegedly, right? That's the idea, is neither can the baddies. So even if you break into the if you manage to break in, but I guess what happens when you how do you, okay, let's model this out. What's the threat scenario in a situation like that? Where does the highest impact attack actually work? Like where would I be able to? I'm not asking to
yeah. You're asking how to succeed of attacking such a model.
Yeah, but let's not give anybody any ideas. But like, where is the system like this vulnerable? Because it's got to be something.
The best the best security product is the one that that are very clear about how they work, right? We're not into security by obscurity. So this is how it works basically. It's based on DFC technology, right? For Aquila specifically, distributed fragments cryptography. There is an ability. We have an ability to run cryptographic operations using fragments of encryption keys without ever combining the fragments. Okay, here you wanted the secret. Here it is, right? So imagine, right, that you have this capability of encrypting stuff using fragments of encryption key that are never combined. Okay, so there is no key, there is no encryption key anywhere during that process. It's based on mathematical functions. Okay, now once you can do that, your SaaS provider, right, like Aquilus, is able to manage all of those different fragments on different regions, on different cloud providers. And one of the fragments can be created and stored on your facility so that Aquilus doesn't have access to all of those fragments. Now, those fragments are also refreshed on a periodical manner. This means, and now I'll give you the answer. You asked how to hack it. So the answer is this. You need to run a simultaneous attack vector on all of those different fragments and to get to them at the same time, including also within your environment. Okay, so malicious attacker, let's say that James, let's say that James is the malicious attacker. James would need to attack both the secrets management system, both the Aquilus Vaultless platform within different nodes and cloud providers, and to attack you, Raf, on your environment at the same time.
Okay, that seems a little bit harder than usual.
Wouldn't the
all right? It's
the
like Die
credential,
Hard 4.
though,
Remember that? Yeah.
Wouldn't the credential exist though on the using system? Like if I'm the Jenkins server that's using the credential to reach out to a database, that credential's got to exist on that server, right? Like, because that's
great question. What I was mentioning right now, and the model that I was just explaining, is the model that is managing the encryption key that encrypts the credentials for the Jenkins. All right.
That makes sense.
So eventually the credentials exist, but how to protect them from any compromise, right? When they are stored somewhere, right? Because every time, right? Always we say, eventually the credentials exist somewhere. So I'm telling you this, if you use it in this manner, the credential would exist only in the memory of the Jenkins machine. That's it.
Right.
This is where they exist.
Now let me, Raf, we've had that. We actually, before we started this recording, I mentioned something about this. When we talk about ransomware, right? There's technologies that are coming out that pick up the key from memory. How does this, what you're talking about now with the fragmented crypto keys, how does that change like the ransomware game to where people are no longer putting the entire crypto key in memory, that these solutions are going and saying, hey, look, I see you use a crypto, I'm going to grab the key from memory and then we can decrypt all the stuff, if they can then fragment.
Please do. That's the whole thing. The whole technology was built in order to stop the dependency, right, of keeping your encryption key somewhere, because the cloud is distributed. In the on-prem world, right, we could have had keys and to protect them on hardware devices, or to say I would never distribute it or I would never replicate it, right? Within the cloud, it's impossible. You need to have one region with a certain encryption key, and then you need that encryption key to open up this data on the other side within the application database, whatever. Okay, but it's not possible any longer. So you need to have those encryption keys. So the whole meaning of the DFC, the Aquilus DFC technology, was to provide this exact answer and solution for those use cases in which you require an access, you require the use of a certain key, but you cannot allow yourselves, obviously, to expose it, and you don't want to have the hassle of replicating it. Okay, so what you do, you have different fragments on different regions of cloud providers, and in order to encrypt and decrypt, the fragments themselves do not need to be combined. So even if you'll be on the, if you'll have that ransomware or whatever, if you'll have this tool that is able to read the memory, okay, it will read the memory and it will not get the master key, because the master key never exists there.
Yeah, that blows my mind just a little bit because that goes against everything that I've ever like thought about.
You've asked for the secret sauce, guys. I told you I'm going to tell you the secrets behind the secrets.
All right. Well, this is fun. I appreciate you sharing because now we're out of time, but that is a very interesting approach. You've created a platform wherein secrets can be shared without anybody knowing what effectively how to. It's like using the Enigma machine, but nobody really knows the entire pattern of that does the encrypting. That part to me still. That's gonna be in my brain for a bit. 'Cause I'm gonna think that through. The math behind it's interesting.
Yeah, you're mostly welcome to visit our website, Akeyless, AKEYLESS.io. Learn a lot.
Okay.
All right.
James, I'm glad you were able to hop back in and ask. And have a good
kind
chat.
of missed you, James.
I know. Sorry, man. I don't know what. Like last time, the same thing. So far,
Okay.
it seems to be pretty steady, though.
Well,
I mean, it says I have good quality, so I don't know why it keeps dropping me, but.
This is what happens when you start talking about secrets, James. The government says, yeah, doop.
Yeah.
All
right. Well, this is great.
Hard question. This is why it was blank. Anyway.
Yes. James with the hard questions on this one. I'm happy to say I'm a passenger on this one. This is not my realm of expertise, but super fascinating. I can see why it's, and the technology is clearly necessary, and the approach is clearly useful, especially as things get higher scale and everybody kind of does. That's the problem, right? It's all these security tools have the same issue as we go into data centers, multiple clouds, other providers. Is how do you create something that you have to do 24 times because you're in 24 different environments? Yeah. So, all right, folks, this is a good natural end. Thanks for listening. I hope you learned something. I'm trying to rack my brain around this a little bit and fit it into my brain cells for later usage. Odin, thanks for joining us, sir. Good to have you on the podcast.
Thank you, guys. Thank you for having me.
That's a great brain dump, and we will catch you guys another time, another place, on another Down the Security